Hey there, thanks for joining me today for this Slowmation about projectile motion. Today we'll be covering some of the basic concepts about projectile motion. As we have said in class, it is important to establish a coordinate system so that we can differentiate between positive and negative vectors. So I'm first going to establish my coordinate system. I'm going to use the following xy coordinate system where I'm going to assign right to be in the positive x direction and straight up to be in the positive y direction. Now that we have established our coordinate system, let's take a look at some projectile motion. In this specific example, we're going to look at a cannonball being shot out of a cannon. But in general, all projectile motion will look something like this. The cannonball is shot into the air and eventually falls back to the earth. The trajectory follows a curved path that looks like this. Let us watch that again, only this time we will include the cannonball's velocity vector and see how it changes through its trajectory. As you notice, the magnitude and direction of the velocity vector continuously changes throughout the cannonball's trajectory, and if we take a few moments of the trajectory and combine them into one image, we can see this more clearly. We can analyze these vectors easier by remembering that we can write one vector as two perpendicular vectors, where one is in the x direction and one is in the y direction. This allows us to break one vector into two, and we can take our image and make it look like this. Now we can analyze the velocities in the x and y directions independently. We will first analyze the x directional velocities and see how they change along the cannonball's trajectory. If you are thinking that the velocity seems to not be changing, you're correct. The x direction velocity remains constant through the trajectory. We know that for velocity to remain constant in the x direction, there can be zero forces acting on it in that direction. This also implies that for equal time intervals, the cannonball travels equal horizontal distances. Now, let us look at the velocity in the y direction. Here, the velocity is clearly changing in magnitude. In fact, it eventually changes direction, going from a positive velocity to a negative velocity. For this to happen, the velocity has to be zero at some instant along the trajectory. This occurs right here at the highest point of the trajectory. We know that for the velocity to be changing like this, there has to be some force acting on the cannonball. For projectile motion, there is only one force that acts on the object, the weight force caused by gravity. And as always, this force acts straight down towards the earth. And as you can see, this force is constant throughout the cannonball's entire trajectory. If we show the y velocities with the force vectors, we can see that the constant force due to gravity is what causes the velocity to decrease as the cannonball rises, and then increase in the negative direction as the cannonball falls back to the ground. We can also quickly look at the x velocities with the force vectors to once again see why the velocity in the x direction doesn't change. The only force acting on the cannonball acts perpendicular to the velocity, and thus has no effect on the velocities in the x direction. So remember, by breaking each velocity vector into two vectors with an x and y component, we can see that the x directional velocity is unchanging, and that the y directional velocity constantly changes magnitude due to the gravitational force. This wraps up our conversation about projectile motion for now, but remember, any object with an initial velocity that is then subject to only a force due to gravity will undergo projectile motion, including sheep. Bah, ram you! Thanks for joining me. Take care.